it's time for the mathematics news. So, we've looked so far at adding complex numbers and multiplying complex numbers. Division of complex numbers is the most involved of these processes. Addition and subtraction is dead easy. Multiplication takes a little bit more time. Division is a longer process. Let me show you what I mean. It relies on a special trick that I need to show you. If I wanted to do this division, let's say we had 3 plus 4i, and I wanted to divide that complex number by, let's do 2 minus 6i. The way to do this is to turn it into a fraction. So I can write this as 3 plus 4i divided by 2 minus 6i. And the special trick in order to organize this is to use a little bit of multiplication. And we're going to multiply the top and bottom of this fraction by this. 2 plus 6i on the top and 2 plus 6i on the bottom. And it's not a coincidence what I've done here. What I've done is I've taken something that looks like this. But instead of having a minus in the middle, it's got the opposite sign, it's got a plus. And by doing this, if you multiply the top two together and the bottom two together, then you end up something which will simplify to be an ordinary complex number. At the moment, we want to try and get rid of anything to do with I on the bottom. It's not really simplified until all of the i's have disappeared on the bottom. It's fine to leave one on the bottom, on the top, sorry, but your answer should be a complex number of the form something plus something else I. And at the moment, it's more of a mess. But by using this technique, then we can simplify the bottom of the fraction. Because when you multiply this, 2 minus 6i times 2 plus 6i, the whole thing simplifies, which is brilliant. So let's just run through the actual process. Okay, so on the top, I'm going to have to do the first outside, inside, last. So on the top, I've got 3 times 2, which is 6. The outside, I've got 18i. The inside, I've got 8i. And at the back, I've got 4 times 6, which is 24. And I've got I squared. And that's going to give me a minus 1. On the bottom here, I've got 2 times 2, which is 4. Then I've got 2 times plus 6i, which is plus 12i. Then I've got minus 6i times 2, which is minus 12i. And at the back, I've got minus 6 times 6, which gives me minus 36. And the I times the I gives me I squared. And what's nice about this, and the reason we do this, is because you will always get these two bits in the middle, which will cancel each other out. You'll always have 2 plus 6i and 2 times minus 6i. And those will always give you two things which will disappear. This I will disappear and these two will disappear. So on the bottom of the fraction, there will be no i's left. On the top, I've got 6 plus 24i squared, which is effectively minus 1 times 24. So 6 take away 24 is minus 18. These two, I can add those together, so I get 18 plus 8 is 26. And on the bottom, these two disappear, plus 12i minus 12i is nothing. This minus 36 times I squared is plus 36. So I get 4 plus 36, which is 40. And then I can just quickly tidy this up. Both of these are divided by 40. So I've got minus 18 divided by 14. And I've got plus 26 divided by 14. And that's got I at the end. And then I can possibly divide those by 2. So minus 9 over 20. And this one I can do 13 over 20. There we go. And that's the answer I was looking for. This complex number divided by this complex number gives me this answer. And the process to get that far takes a little bit of time. And it relies on what we're doing here, which is multiplying the top and bottom by 2 plus 6i, which was something which is related to this. And this special trick means that the bottom simplifies really nicely. Let's do another one. Okay. This time I'm going to have, I don't know, 5 plus 7i. These are going to be horrible numbers. And here I'm going to have, let's just have 1 plus I. Okay. So what we need to do, if that's the division sum we're going to try and do, we multiply the top and bottom by what we call the complex conjugate of this. The complex conjugate is the same number, but instead of a plus in the middle, you have a minus. Or if you have a minus in the middle, it becomes plus. It's whatever this is, but the opposite sign. So here I'm going to multiply by 1 minus I on the top and the bottom. Effectively, I'm not changing the answer to this sum, I'm multiplying by 1. But by doing this process, you simplify the bottom. On the top here, I've got the first two, 5 times 1. I've got the outside two, 5 times minus I. The inside two is plus 7i. And the last two, I get minus 7i squared, which is the same as 7. You've got I squared is minus 1, so 7 times minus 1 times minus 1 gives me plus 7. On the bottom, I've got 1 plus 1, 1 times 1. The outside 2 gives me 1 times minus I. The inside 2 gives me plus I, which is lovely. And at the back, I've got I times minus I, which gives me minus I squared. And then I can simplify everything. 5 plus 7 is 12. Minus 5 plus 7i is plus 2i. Here, these two disappear, which is lovely. And then 1 take away minus 1, which is the same as 1 plus 1, which is 2. That simplifies down to be 6 plus 2 divided by 2 is 1, so that's 6 plus I. Phew. If you have a plus bi divided by c plus di, you write it as a fraction. And you multiply the top and bottom by something that looks like this, but with the opposite sign in the middle. C minus di. Like that. And then on the bottom, you're always going to end up with the first two will give you c squared. The outside two will give you minus cdi. The inside two will give you plus cdi, so they disappear. At the back, you're going to end up with d times minus d times I squared, which is minus d squared times minus 1, which gives you plus d squared. On the top, there's going to be something else. But this process means that all of the i's disappear, and you end up with a nice answer. So give this a try. I've got some practice questions for you. Good luck.